When doing a stoichiometry problem, the first thing we need to do is make sure that we have a balanced equation to start. In this problem, iron and oxygen gas are reacting to form iron oxide. So first we need to look at our balanced equation. We see that we have 1 Fe for iron in the reactants and 2 Fe in the products, and we have 1 unit of O2 in the reactants and an O3 in the products. Since the oxygen is more complicated, we'll start there. First, we know that since we have a 2 and a 3, we'll probably need to switch them. So if you have an O2 on one side and an O3 on the other, you can put a 3 in front of the O2 and a 2 in front of the O3, and this gives us 6 oxygens on each side. So now the oxygen is balanced. Now we can look at the iron. We have now 1 iron in the reactants and 4 iron in the products. So we need a 4 in front of the iron on the reactant side. Now our equation's balanced. The second thing we need in order to do stoichiometry is to know the molar mass of the various elements and compounds we're working with. In this question, we're told that we begin with 53.6 grams of iron, and we want to know how many grams of iron oxide can be produced. Therefore, we'll need to know the molar mass of iron and of iron oxide. To find the molar mass of an element, we can simply look at the periodic table. Here we have the periodic table, and we look and see that iron is here in the middle, and it has a molar mass of 55.85. Our units on molar mass are grams per mole. To find the molar mass of something more complicated like iron oxide, we multiply the molar mass of the single element times the number of times that element appears in the compound. So for iron, we'll multiply 55.85 times 2, and for oxygen, we'll multiply 16.00, which is the molar mass of oxygen from the periodic table, times 3. This calculation will give us a molar mass of 159.70 grams per mole for iron oxide. Now we have the two things we need to start the problem. We have a balanced equation and we have the molar masses. First, we write down our starting known value, 53.6 grams of iron. We know we want to end up knowing how many grams of iron oxide we have. And to get from grams of one substance to grams of another substance, we have to go through the molar ratio that we find in the balanced equation. But first, we have to get from grams to moles. To do this, we need a conversion factor for the molar mass. We always want to make sure we can cancel our units, so we'll be putting grams of iron on the bottom of this ratio and moles of iron on top. We use our molar mass, so we see that we have 55.85 grams of iron in 1 mole of iron. So this takes us from grams of iron to moles of iron. Now we need to find the ratio of iron to iron oxide in our balanced equation. We always want to be able to cancel, so we have to put moles of iron on the bottom, and we're going to put moles of iron oxide on the top. We use the coefficients from our balanced equation to determine what the molar ratio is going to be. Here on Fe, we have 4, so we'll have 4 moles of iron, and here on the iron oxide, we have 2, so we'll have 2 moles of Fe2O3. So this has gotten us from grams of iron to moles of iron, and from moles of iron to moles of iron oxide. But we want to know how many grams of iron oxide we can have, so we need a final conversion. We're going to need to go from moles of iron oxide to grams of iron oxide. To do this, we'll use the molar mass for iron oxide that we calculated before. It will be 159.70 grams of iron oxide in 1 mole. Now all we have to do is complete the calculation to find our answer. Once we've put these numbers into our calculator, we should find that we have 76.6 grams of iron oxide.